All right. So besides just figuring out probabilities and how data is distributed, one of the important things in AP Psych and also in psychological and sociological research is correlation. And so when one kind of behavior or trait accompanies or follows the other, we say that the two correlate. So for example, how tall you are and how big your feet are two things that correlate with one another. Somebody who has a size 12 foot is usually tall. Somebody who has a size 6 foot is usually short. How high your IQ is and how well you do on the SAT are correlated, not as strongly as you might think, but they are positively correlated. So if you have a higher IQ, you're likely to get a higher score on the SAT. Now, an interesting difference to that, and the reason I use that as an example, is the SAT is not a good measure for students with disabilities or students with other kinds of challenges often. But when we accommodate for those disabilities, we get much closer to the SAT measuring actual intelligence. And so that's kind of where accommodations came from, which I just thought was an interesting thing to throw out there. So there's a statistical measure for correlation that's called R, and there's a way to calculate it by hand, but almost every package that you might use for data, like Excel, Google Sheets, there's a statistical language called R and Python. They all calculate R for you. And so R is a measure of how closely two things are related to one another. And if they go together, we say that's positive, like foot size and height. If they're opposite, like the smaller the foot size, the taller you would be, then we would say that's negative correlation. And the closer you are to 1, the stronger the correlation is. And the closer you are to 0, the weaker the correlation is. And so a correlation value of 0.8, positive 0.8, might be a good estimate for height and shoe size, or size of your foot. Correlation between warm weather and how likely someone is to be a good skier would most likely be a strong negative correlation. Scatterplots are one way of showing data, where you show the two different quantities are graphed versus each other. So a data point for example, shoe size. Shoe size might go up the left and height might go on the horizontal axis. And then for each different person that you had data on, they would be a point on your scatter plot. And in that particular example, you would see a good graphing of data, or a good line, good positive correlation kind of trend line. And in Google Sheets or Excel, you can actually just have it. You click a box and it adds the trend line, and you can tell. It'll give you an estimate for R that way, which is pretty easy. All right, and so the scatter plot here shows a perfect negative correlation. And then the one on the right, they're just all over the place. Like, you cannot imagine drawing a line among those. And so you see that has no relationship at all. All right, so this is just a set of data that shows height and temperament of people. So if we look at it for a minute, so we have 20 subjects, and their height ranges from, it looks like, biggest number I see is 80, the smallest number I see is 60. 60 is the smallest. And then measures of their temperament, looks like it goes from 90 down to 30. So when you're just looking at it, do you see any kind of relationship? 80 to 75 is close, but temperament's lower. 63 to 66 is close, but temperament's higher. Number 3 is about the same. So just at a glance, I don't see much, but it's really hard to look at those tables of data. It's a lot easier to look at a scatter plot. So this is a scatter plot that took all of those people, all of those men, and ordered the data. Obviously, you keep together height and temperament, and then plotted them. So height is on the x-axis and temperament is on the y-axis. And here you can see there appears to be, you can intuitively feel like there is a line that goes through those. And in fact, I don't have a plot of it, but there is a line that has a positive slope of 0.63. Okay, so going right back that data to our last slide here, essentially, I don't have an intolerant people seem to have better temper. What we did was touch on very shallowly a whole lot of topics. And so making sense of, instead of this big giant long list of numbers, making sense of the numbers, particularly with normal distributions, and we talked about different aspects of that. This isn't a scatter plot, but it is a plot of two different characteristics and how they're related to one another: age and screen time, and how it changes over time, and how you can look at three different pieces of data all at once. So it's complicated. I have a really good Quizlet that goes over a lot of this because it's vocabulary in the main part. And then what we're going to do is look at some of the free response questions and how we can highlight different terms to help break down and then be able to answer some of the questions. But the main goal is to get you to the place that you know the vocabulary and you know, like I said, at a shallow level, roughly what normal distributions mean, how measures of central tendency work, how measures of deviation. So not how to calculate them and not how a statistician would be able to do them, but that you understand conversationally and you can read scientific papers and, basically understand what they're talking about, which honestly is a good skill for life. All right. Well, I appreciate you joining me for this, what turned out to be a little bit longer than I expected video, and I look forward to working with you.